Hello friends, this is Meenu Yadav and today I am going to start basic physics for radiology for any preparation regarding radiology examinations and also for JR and also for the students of radiology. So let's start it. This is from the starting and I will continue this series by thoroughly, and here is the contents of my measurement basic absolute system of units, fundamental and derived units. And here is the first topic of our today lecture is measurement. We have read this topic in 12th also. So measurement is given by its unit. Measurement means magnitude of any unit. So the laws of physics are expressed in terms of physical quantities, and measurements of any physical quantity is a number, and any idea about its magnitude is given by its unit. Thus we see that the measurement of any physical quantity consists of two parts. The first one is numeric part. The numeric part is the measure of the physical quantity. It is purely a number. And the second part is the unit employed depends upon the nature of the physical quantity. Such as we see any example, and suppose length of a table is 2.5 centimeter. So here the numeric part is 2.5 and unit part is centimeter. So now this way we can understand measurement have two parts, numeric parts and unit part. Okay, so the direct comparison with standard unit is called direct measurement using a meter scale. On the other hand, the distance of the moon from the surface of earth cannot be measured by direct method. Therefore the indirect method of measurement become necessary. The distance of moon can be measured by sending a radar signal or laser beam to the moon and then receiving its echo. If one is the time taken by the radar signal to go to the moon and come back, then distance of the moon would be, here we can see, here is the sun and its surface and distance from the earth. Okay, and now we will erase it. Okay, we are going to erase this. And distance of the moon would be speed of signal into total time upon 2. So suppose its distance would be represented by s, and speed of signal would be represented by c, and total time would be t by 2. So here c means distance of moon is equal to 3 into 10 to power 8 meter per second. Some units which are frequently used for short and length are, and these are Fermi, angstrom, light year, parsec. These should be remembered for many times, and so many of you have remembered these previously from your 12th classes also. So we know that 1 Fermi is equal to 10 to power minus 15, and 1 angstrom is equal to 10 10 to power minus 10 meters. 1 light year is equal to 9.46 into 10 to power 15 meters. Distance traveled by light in 1 year. So 1 parsec is equal to 3.08 into 10 to power 16 meters. Distance corresponding to an annual parallax of 1 second. If theta is small, then sin theta is equal to theta, then 1 it would be 1 upon r. So CVV would be its distance, because q is equal to 1 second. So 1 second is equal to 1 degree upon 3600. It would be 1 degree is equal to pi and upon 180. So 1 pi upon 180 would be 1 radian upon 3600, because 180 degree is equal to pi radians. So now radius would be CB upon Q. This is from this figure. Here you can see the figure. This is the figure. CB, this is the moon, this is sun, and this is our earth, and this would be the radius. Okay, so for now we would look at here. Here is the we have put the value of these distance from the sun and radian, 3600 meter distance upon pi. Okay, by definition r is equal to 1 parsec. So by solving all this, here is the answer is 3.08 into 10 to power 11 meters. So now basic absolute systems of units. There is some basic absolute systems of units have been presented here are CGS system, MKS system, SI system, FES system. We know that CGS means centimeter gram second, MKS means meter kilogram second, SI means international system of units, FES foot pound second. So here is the most accurate system is the SI system. Okay, and we also know that units should have some qualities, some characteristics. So these are, it should be well defined and should be of a suitable size. It should be easily and accurately reproducible. It should not be affected by change of temperature, pressure, time and other physical standards. It should be easily comparable with other similar units. So now we are going to read our system of measurements, and here is the SI system represented. In SI system there is 7 units and there are 7 fundamental quantities, and these units are meter, kilogram, second, ampere, Kelvin, candela and mole. So what is meter? Meter is a bar of platinum iridium alloy kept at the International Bureau of Weights and Measures at Chevre near Paris. The distance between two lines engraved on gold plugs near ends of the bar at the temperature of 0 degrees Celsius is called 1 meter. A similar bar is also kept at National Physical Laboratory, Pusha, Delhi at temperature 273.16 Kelvin at 1 bar pressure. All other meters are calibrated against this meter. Okay, and its modern definition of meter is the standard meter is now defined as length equal to 1650763.73. This is the 1650763.73 wavelength of red-orange light emitted by krypton isotope of atomic mass number 86. This is more satisfactory standard than the platinum iridium meter, as krypton atoms are easily available in any laboratory. Moreover, wavelength of light is not affected by temperature, time and environment. We use optical interferometer to measure wavelength of light. Okay, so let's move to the next. It's kilogram. The standard for mass is kilogram, which is the mass of cylinder of platinum iridium alloy in controlled environment at Sèvres near Paris and Ampere, Delhi. So next one is the second. Second is the one day is defined as the time taken by the earth to complete one rotation about its own axis. The day has been divided into 24 hours. Each hour is further divided into 60 minutes and each minute into 60 seconds. 1 second is 1 by 86,400 part of a day. So 1 second is the 1 by 86,400 part of a day. Since a day is not constant but varies throughout the year from season to season, hence a second has been defined as hence a second has been defined as and 1 by 3,155,692.97 part of the solar year 1900 AD. So now the standard of time is based upon the atomic clock. This refined second is equal to the times taken by cesium atom of atomic mass number 133 of to vibrate in and it will vibrate to. You don't have to remember this, but this is just for the knowledge. Okay, so it is to vibrate 91926317770 times. Oh my god. So let's see the ampere. We don't have to give them too much time, but we have to revise these topics. Ampere in the field of electricity, the basic quantity is current intensity and its unit is ampere. It is defined as the current flowing through two thin infinite length parallel wires and placed in vacuum at a distance of 1 meter from each other, which produces a force of 2.10 to raise to minus 7 Newton per meter length between them. So the electromagnetic unit of current is based on the magnetic effect of an electric current. It is defined as that current which flowing in a wire unit length bent into the arc of a circle of unit radius produces at the center of magnetic field of unit intensity, and the intensity of magnetic field is equal to 1 gauss, length would be L, and current would be C, and radius of coil would be R. And let's see the Kelvin. Kelvin is the unit for the measurement of temperature in SI system. The 0 of Kelvin scale is chosen as minus 273 degrees Celsius. 0 is taken as minus 273 degrees Celsius. 0 Kelvin, and is known as absolute zero. Each degree on this scale is equal to 1 unit on Celsius scale. The boiling point of water is 373 Kelvin. What is the boiling point of water? 373 degree Kelvin. And any temperature, say 1 degree Celsius, corresponding to the, if we are taking this with the degree Celsius, then what is the formula? Is T plus 273. We have to add just 273 into the degree Celsius. Then we will take a, we will find a Kelvin. Okay, candela. So let's see the candela. Candela is the unit of measurement of luminous intensity or illuminating power of a source of light. And here, last but not the least, mole. It is the unit of amount of substance. It is more used in the chemistry. Okay, so let's see our next topic. What is this? And next topic is fundamental and derived units. So it is difficult to remember a separate unit for each physical quantity. Thus we regard some physical quantities as fundamental quantities. Their units are fundamental units. And what happened here? Yeah, we have to see this. Okay, so all physical units can be expressed in terms of only 7 fundamental units, which we have read behind. These are length, mass, time, temperature, luminous intensity, electric current, amount of substance. And let's revise their units. Length has meter, mass at kilogram, time second, temperature Kelvin, luminous intensity candela, electric current ampere, amount of substance has mole, its unit. Okay, and all other physical quantities are defined in terms of these fundamental quantities and their units as derived units. For example, watt, and it is the unit of power, and coulomb is the unit of charge. So what is the unit of electric power, and may be defined as the power required to maintain a current of 1 ampere flowing under a potential drop of 1 volt. So what is the ampere into volt? 1 coulomb is equal to 1 ampere upon second. And matter, what is matter? Matter, it is defined as anything that occupies space and has inertia. It is in about 400 BC that Democritus first suspected for matter having invisible and indivisible particles called atoms. Okay, so now we have finished this topic. Thank you guys, and we will meet soon with another very interesting topic. Okay, bye bye. See you soon. Love you.